In this 1.4.CYU-1, we want to find the limit as x approaches 4 of x squared minus 3x minus 4 over x minus 4. Now this is one of the types of problems where it breaks it down into steps and there's also parts. So first it asks us some things like, is our function f of x equals these terms defined when x equals 4? Or they're asking, can you actually find f of 4? Well, what happens when you try and plug it in? You get 4 squared minus 3x minus 4. Nope, sorry, 3 times 4 over 4 minus 4, which equals something we don't really care what over 0. And that's a big no-no. You can't divide by 0. So f of x is not defined at x equals 4. Okay, so I've done that. Let's go on to the next part. Does our function need to be defined at x equals 4 in order for it to have a limit? No. If you were to graph this function, it looks something like a straight line. But at x equals 4, there's a big hole. It's not actually defined at x equals 4. It's defined everywhere else, but not at x equals 4. So the question is, can you find the limit if there's a hole there, if there's a point where it's not defined? Well, sure, you can say as I come from this direction or this direction, it gets closer and closer to this value right here. It might not actually be defined right there, but it is getting closer and closer to that y value. So the limit can still exist, even if f of even if f of 4 is not defined. Okay. So next step, well, we figured out we can't just plug the 4 in because then we end up dividing by 0. So what do you actually do in a situation like this? You factor. Okay. So we were trying to find the limit as x approaches 4 of x squared minus 3x minus 4 over x minus 4. So to factor this, now each time I do this until I actually take the limit, until I actually plug in my 4, I'll just keep writing my limit sign, even though it's kind of annoying. And you factor the top. So this would be x minus 4 times x plus 1. And if you don't remember how to factor, go look up some YouTube videos on it, over x minus 4. Notice those x minus 4s can cancel, which is just what we want. So now we're trying to take the limit as x approaches 4 of just x plus 1. And that's very simple. At this point, let's plug the 4 in again. So we'll just have 4 plus 1, which is 5. So even though it wasn't defined right there, it's getting closer and closer to 5, so my limit is still 5.